Please open in your learning workbook to page 173, and let's complete an example showing how we graph exponential functions. Graph the functions f of x equals 2 to the x power and g of x equals 1/2 to the x power. We will do this by plotting points. We will assume various values for x, plug them into each equation to get the corresponding values for y, and then take those ordered pairs and plot them on our graph. Okay, let's start by making a table. Okay, we're going to use this function right here, and we're going to pick some values of x. Now, in the example, the recommended values for x are -3, -2, -1, 0, 1, 2, and 3. And so we're going to plug in each one of those values. Now, f of x is the same thing as y, so we have y equals 2 to the x power. And when we plug in each value of x, we'll find y. So if x equals -3, then y equals 2 to the -3 power. Now remember your intermediate algebra rules. Whenever you have a negative exponent, you can get rid of that negative exponent using this rule. A to the negative n is the same thing as 1 over a to the positive n. So similarly, 2 to the -3 would be the same thing as 1 over 2 to the positive 3. Of course, 2 cubed is 8, so we get 1/8. So if x equals -3, y equals 1/8. Let's continue. If x equals -2, then y equals 2 to the -2, which is 1 over 2 to the positive 2, which is 1/4. If x equals -1, then y equals 2 to the -1, which is 1 over 2 to the 1, which is 1 over 2, 1/2. If x equals 0. This one is tricky, and the underprepared student will make a mistake here. I don't want any of you to be the underprepared student, so remember this rule. A to the 0 power equals 1. Okay, let's apply the rule. So if x equals 0, then y equals 2 to the 0 power, which is 1. Any non-zero number raised to the 0 power gives you 1. All right, we're just a little bit beyond the halfway mark now. All right, let's proceed. If x equals 1, then y equals 2 to the 1, which is 2. That's easy. If x equals 2, then y equals 2 to the 2, which is 4. Also easy. If x equals 3, then y equals 2 to the 3rd, which is 8. And now we've completed our table. Now, there's something that I want you to notice about this table, and it's connected back to the previous video. In the previous video, we talked about the salary doubling each day. That's kind of what's going on here. If you think about it, this right here, the 1, the 2, and the 4, and the 8, make very clear that we have the same pattern we did in the previous example. For example, it was 2 cents on the first day, and then it doubled to 4 cents, and then it doubled to 8 cents. One of the properties of exponential functions is that for a 1 unit increase in x, there is a multiplying or a dividing of y. In this case, as we move down the table, we notice the pattern, which is multiplying by 2. But if we go up the table, the pattern changes to dividing by 2. Let's take a look at that. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. Because if you take one pizza and you cut it for 2 people, then each person gets 1/2. 1/2 divided by 2 is 1/4. If you now take half of your pizza and you make that available to 2 people, each person will get 1/4. And 1/4 divided by 2 gives you 1/8. If you cut 1/4 in half, then you're getting 1/8 of a pizza. So we can see here that there is a pattern in the table, and knowing that pattern helps us solve problems quickly, as well as helps us to identify if we've made any mistakes. All right, so now we're going to create a graph using this table of points. Something I would like you to notice is that all of the y values are positive. So when we make our graph grid, there is no reason to include quadrants 3 and 4. We're going to focus solely on quadrants 1 and 2 of this part of our algebra together. All right, so let's go ahead and make our graph grid. So the y's go up as high as 8, so let's just call the very top 8. Then half of that would be 4, half of that would be 2, half of that would be 1, half of that would be 1/2, half of that would be 1/4, and half of that would be 1/8. All right, the x values range from -3 to +3. Okay, so now that we have all of our axis labels in place, we can plot our points and begin to create our graph. All right, here we go. So let's work up the table, starting at the bottom. 3, 8. So there's 3 on the x, 8 on the y, gives us that ordered pair. 2, 4. 2 would be here, 4 would be here, so we get that ordered pair. 1, 2 would be here. 0, 1 would be here, that's our y-intercept. -1, comma, 1/2. So starting at the origin, that's 1 step to the left and up 1/2 a step, which would be here. -2, 1/4. That's 2 to the left, up 1/2 of a step, or 1/4 of a step. And then 3 would be 3 to the left, and then up 1/2 of a step, which is 1/8, which would be right here. All right, now we're going to connect all of our dots together. And this is what our graph looks like for our function f of x equals 2 to the x power. Now I want you to notice something about this graph before we move on to our other equation. As we travel from right to left along the graph, this orange curve is getting closer and closer and closer to the x-axis. But will it ever reach it? And the answer is no, because think about what's happening as you move this way. As you move leftward along the graph, the x values are decreasing, which means that's moving up this chart. What happens to the y values as you move up this chart? 8, 4, 2, 1, 1/2, 1/4, and 1/8. These are all positive numbers. The next number in the sequence is found by dividing by 2. So you're having a positive number divided by another positive number, which means you'll always have a positive result. No matter how many times you divide a positive number by 2, you're still going to get another positive number. The values are getting smaller and smaller and smaller, and will never be 0, because a positive divided by a positive gives you another positive. So this gives us an interesting trend line called an asymptote. An asymptote is a line that your curve forever approaches but never reaches. For this exponential graph, the x-axis is an asymptote of the orange curve. The orange curve forever approaches but never reaches that green dashed line. All right, we're now ready to turn our attention to the other graph, g of x, which is equal to 1/2 to the x power. All right, so let's create a new table. Actually, let's leave the table for f of x where it is. That'll be useful for comparison purposes, and we'll just use the space around our curve in order to solve this. All right, so here we go. So we've got g of x, which is equal to 1/2 to the x power. Again, g of x is the same thing as y, so we have y equals 1/2 to the x power, and we're going to make a table over here. We're going to use the same x values as before, only this time we're going to get different y values because we have a different equation. All right, here we go. So let's go ahead and proceed. Y equals 1/2 to the x. If x equals -3, then we have the following. Y equals 1/2 raised to the -3 power. Now, before we simplify this, let's remind ourselves of another convenient rule from intermediate algebra. We have the following rule. A over b to the -n is the same thing as b over a to the +n. In other words, when you have a fraction raised to a negative exponent, you can just flip that fraction over and change the sign of the negative exponent to positive. So that's what we're going to do here. Instead of 1 over 2 to the -3, we'll have 2 over 1 to the +3. Well, 2 over 1 is just 2, and 2 cubed is 8. So we get the value 8. All right, how about if x equals -2? Well, then we have y equals 1/2 to the -2, which is 2 over 1 to the +2, which is 2 squared, which is 4. If x equals -1, then y equals 1/2 raised to the -1 power, which is 2 over 1 raised to the first power, which is 2. All right, what if x is 0? Then we get 1/2 raised to the 0. But we know that any non-zero number raised to the 0 power is 1. So we get 1 for our answer there. All right, once again, we've crossed the halfway mark. Only a few more x values left to go. All right, if x equals 1, then y equals 1/2 to the first power. Well, anything to the first power is itself, so we just get 1/2. If x equals 2, then y equals 1/2 squared, which is 1/2 times 1/2, which is 1/4. And finally, if x equals 3, then y equals 1/2 cubed, which is 1/2 times 1/2 times 1/2. You know how multiplying fractions works, right? Just multiply across the numerators to get your new numerator. 1 times 1 times 1 is 1. And multiply across the denominators to get your new denominator. 2 times 2 times 2 is 8. So we get 1/8. Now there's something I'd like you to notice about the values in these two tables. They're the same, they're just in the reverse order. This one went from 1/8 to 8. This one is going from 8 to 1/8. So these are going to be really similar points that we are about to plot. Let's go ahead and create our graph now. All right, so -3, 8 would be this point right here. -2, 4 would be here. -1, 2 would be here. 0, 1 would be here. That's a point that both equations have in common. 1, 1/2 would be here. 2, 1/4 would be here. 3, 1/8 would be here. And once again, we notice that there is an asymptote for our curve, because these values are going to approach but never reach 0. All right, so we have now created the graphs for f of x equals 2 to the x and g of x equals 1/2 to the x.